Good morning, good afternoon, or good evening, depending on where you are, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Sonatype. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead of us, but before we begin, I have just a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our conversation or you'd like to rewatch or reshare, the on-demand recording will be made available shortly after we conclude our webinar today. If you have any questions for Sal, we want you to put those into the Q&A box on the right side of the screen. And that's also where you'll find the chat box, where we want you to engage with your other attendees. Finally, at the conclusion of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. So stick around to see if you're one of our winners. So our topic today is Log4j's impact on software supply chain management. And I'm joined today by Sal Kimmick, developer advocate at Sonatype and an advocate for Log4j awareness. So it's my pleasure to turn the floor over to Sal to get us started. Thank you so much for being with me.
Absolutely. Well, welcome everyone. If you joined us for the last episode, we really covered in the last webinar a little bit more about the technicalities of Log4j, how and why it works. We'll recover a little bit of that, but today I really want to go into the open source supply chain, what that means for you and the way that you work, and how it's changing with the new set of cybersecurity attacks that we're seeing. And if you follow this in 1 week's time, we're going to discuss a little bit more about how that might be changing the culture of development in your own enterprises. So today, this is what we're going to be covering. We're going to break this down into 4 parts. So first, we're going to explain why there is a new wave of cybersecurity attacks, where these vulnerabilities are entering your supply chain, how Log4j has impacted the software supply chain management as a really catalyzing event. And last, we're going to cover why the mean time to update might improve the way that the entire global supply chain works and the way that you can engage with that as a metric that might improve your ability to be secure moving forward. So first, what is the software supply chain? If you are working in enterprise of any scale, it really looks a lot like this. Typically, you're going to be pulling in open source components. These are the packages that you're pulling from PyPI, from Maven Central. These are the subcomponents that allow you to build out code really effectively and really quickly as you compose those into your source code. That's really what you would recognize as your code base. Then typically you're going to containerize this. And if you're doing really well, you're doing an infrastructure as code layer to this, allowing you to automate and scale this as you need to. Now, the reason I'm here to talk to you today is because I come from Sonatype, and for over 10 years, Sonatype has been responsible for the generation initially and some of the ongoing management of Maven Central Repository. So this is the central repository that handles every single Java package that goes through. And we continue to track every package that goes through that, as well as those from other ecosystems. And we'll explain a little bit about how we have the statistics behind this that you may not get elsewhere, and a perspective on this that's much more global and much more sort of tracing with real time than you might get from other corporations. But I think what's really important to understand is how drastically software development has changed because of open source in the last decade. It used to be that you would be building out most of your components. That has completely shifted in the last 5 years, particularly. And in 2021, we found that over 90% of enterprise source codes were composed entirely of open source components. Now, if you joined me last time, I put this to you the same way. A good way to think about this is that right now, if you have 90% open source components in your source code, you can think of that really as having 9 out of 10 of the developers underlying your code base as being strangers on the internet that you don't know. Now, most of these are not malicious. The majority of them are just trying to build good packages that help you to solve hard problems. But that also makes them vulnerable because you cannot know what the intent is or what the quality is of all of these packages that you're taking in. And more so, a lot of these open source packages come from a sort of generation of open source that was done almost entirely voluntarily. So it is true that some of these packages that are being maintained do come from that one random person in Nebraska who's been maintaining it since 2003, oftentimes without pay. Now, this came at a time where there were not so many supply chain attacks, and many of these individuals or groups are small, very dedicated, but do not have security training and may not be able to capture when a contribution that's malicious to their package is actually intended to do harm, not just to their package, but specifically for the downstream effects of anyone that's using it. And I think Log4j has been an incredible example of that we'll really be able to dive into. But before I get started with this, what I really want you to take home today is that Log4j is just one exemplar. It is just one event that got a lot of publicity. This is something that's happening all the time, and that's because of the way that open source has absolutely exploded. In the last year alone, we've seen that there has been a massive increase in all of the major ecosystems that we depend on. Here we're seeing just Java, JavaScript, Python, and NuGet, but we're seeing a somewhere between 50% and over 90% increase in the downloads and utilization of open source in order to support the development acceleration that we all depend on to get our features out on time. Unfortunately, what that means is it's become an incredibly large surface area for malicious actors to step in and find a new way to get into your source code. And we saw just between 2020 and 21 a over 650% increase in these software supply chain attacks. I cannot explain to you enough. This is the new age and the new wave of cybersecurity attacks. So we need to understand them, what they are, and how we can be protecting ourselves from them in real time. Because when you're looking at statistics like this, it is never the question of if you are going to be impacted by a supply chain attack. It's a matter of when. And the one note on this that's important to understand is they're not going after obscure packages. They are primarily going after the most densely downloaded applications available. So they are trying to go for things like Log4j example that are available in almost every code base that depends on them. Now, Log4j is a Java package, but it's utilized in almost every other primary ecosystem code base. For example, this hit a lot of Golang architectures. There's just no reason for any developer to build out their own logging system if we have something that's so well developed, so well known, and so well integrated. And it's that integration across hundreds of thousands of different source code bases that made Log4j such a good target for malicious actors. And lastly, as I continue to tell you this story about the single circumstance of Log4j, I'm showing you an example of our vulnerability timeline that we update in real time whenever we capture a new event. This is showing you that in every single month so far this year, we have had not just one, but multiple serious malicious actors that we have captured and been able to report not just out to CISOs, not just out to developers, but we're reporting them back to the central repositories that they come from. So do understand that when I'm giving you this one case, this is an example that there are dozens of in a given month, and that you really have to be aware that it's not just coming from Java, it's coming from all over the place. And there's different reasons, different vectors, different attack styles for them. But I would absolutely encourage you to look at this vulnerability timeline as you start to understand what these look like and potentially how it could be coming into your base. So that brings us back to what exactly it is that makes open source so susceptible. And what I want you to understand is it's not because the developers that are creating these open source packages are incompetent. In the case of Log4j, these were incredibly competent developers. They got the message on the 0 day, they did updates in real time, and they made sure that the package and the newest version that was going out was secure. It has been secure. Every update has allowed that to be so. And it was really in showing that this was an incredibly responsible open source management group that allowed this to not be as big of a disaster as it could have been. Unfortunately, the problem that we're seeing now is that there are many enterprises out there that are not downloading the current and no longer vulnerable versions. And that's really where this system breaks down. The onus is not on the open source developer to ensure that their package is vulnerable. They've done that in this case. If you have not gone in and been able to refactor your code base and take that least vulnerable version or that non-vulnerable version, then you're still going to be insecure. So let's review a little bit about why Log4j was so easy for malicious actors to take hold of. It really comes down to not the design of the package itself, but really some fundamental flaws that happen in Java. So Java is very, very easily serialized, and if you want to deserialize it, it makes it very hard and much more computationally expensive to handle in the JVM. So if you are looking at doing a logging function with Log4j, unfortunately, what this would do was allow you to interface directly with the JNDI. And this would give you an unauthenticated remote code execution. So you could actually go in as an end user using this code and insert executing files into a code base that you otherwise wouldn't and shouldn't have access to. And this is really how this became so powerful. This was not just a way for them to take out information. I gave you in the last session examples of them taking databases, names, holding them for ransom. But more importantly, they can put in essentially sleeper cells of execution code that could be sitting there to this day if you do not update. And as we covered how this works, really this allows them to use this simple executing string, this single string that allows you to capture the data that is whatever they are intending to log, and it allows them to put executing code within. So this is really a 2-for-1 deal for a malicious actor. And both of those combined allowed them to be able to get into very large enterprises and to be able to have a negative impact on them. So really, what is this looking like? And if you were in my last session, we covered this very briefly, but the traditional model of dealing with cybersecurity concerns breaks down a little bit when you're looking at the acceleration of these cyber attacks. It used to be that you'd have a little bit of time to be able to understand, to be able to do a fire drill around what the potential concerns could be for a attack of a given type. But every single one of the actors within an enterprise has a different motivation for being there and a different thing that they're tied to. So a developer is really just interested in understanding, how hard is it going to be to upgrade this? Is this going to break my build? Operations wants to know where they have it running, how well is it running, what's our uptime? Security wants to know, are we going to be able to mitigate vulnerabilities? Are we going to be able to handle a 0-day? And again, a 0-day is just the date at which a vulnerability is made public, allowing the malicious action. The malicious actor is already aware, they've already made the breach. But the 0-day is the day that other individuals and other malicious actors may become aware of it. And there's going to be much more scanning of source code to see if they can break in and utilize that to their own gains. Legal is pretty strictly concerned with the compliance of this. Is this something that we're going to see an issue for? Is there an SLA concern here, a systems level agreement that we need to be concerned with? What do we need to disclose, and when do we need to disclose it, and to whom? And DevOps really wants to make sure that they understand where in the software delivery lifecycle it's being downloaded. Is this in production? Is it pre-production? Where can we capture it? How can we be handling this as we are trying to do continuous delivery? And this is really where this broke down with Log4j, because we're typically seeing single instances of events, possibly a single refactor. But really in this case, we were finding that there was so much attention on this specific case that many malicious actors were going in, finding new and interesting ways to exploit this. And we have had several versions of having to update this. Now, if you do not have an efficient way to communicate across every single one of these typically siloed sections of an enterprise, you're not going to be able to handle this new type of cybersecurity wave. We need to be able to update these in real time, create resilient software architectures that allow you to make updates that are not going to break your build. And I really have to bring this point home because these statistics are from today. If you think that you do not have a vulnerable version of Log4j in your source code, I would question that, because today this has ranged between 38 and 44% of vulnerable downloads still occurring. So only 60% of software architectures out there are genuinely hosting the most secure version of the most popular malicious attacking vector that we have seen for years. So this can be for several reasons. It may be that you have not scanned it accurately. It may be that you're not aware of it. This could be sitting in your jars. This could be sitting in your Uber jars where it's incredibly hard to scan. If you have not had a previous practice of really having a bill of materials, or what we'd really call sort of the nutrition's facts of your software, you may not be able to capture this, know where it was, know when it was downloaded, and that is creating an open back door for any malicious actor to still be able to walk in. And I cannot explain this enough. It amazes me that we're sitting out from this massive 0 day several months later and still seeing this hovering around 40%. You can see that that's almost a straight line for the last month. And I'm incredulous to that. And it's the reason why I'm on this call today, because I want to move that line. That line is a matter of enterprise security. That line is a matter of national security. We have to pay attention to it. And I do want to drive home the point here that, again, this is no individual nation that's doing it extraordinarily well or extraordinarily poorly. This was an international event, and everyone has been impacted by it. If you saw my last talk, we went into some details about how different nation states have been severely impacted in this as we go into these difficult times. If you do not capture this in real time, you're opening your enterprise to ransomware, or you're opening up really sensitive databases to be exploited. Now, there's been a lasting impact of Log4j. I think it has been a really positive catalyst for making sure that there's an awareness on every level, not just on developers, not just on security researchers, but even at the level of government. Now we're beginning to understand that this is a type of vulnerability when they're this massive, when they're, you know, 2/3 of the internet is using this in their source code. This cannot be something that you ignore. And in order to ensure that, there has been an emergency directive from the Federal Trade Commission that's ensured that enterprises and nation states are putting into practice and mitigating this, or they risk legal action. This is not something where they're coming down with a heavy hand for a, arbitrary reason. It's because the concerns here are severe. The impact of this is severe. Again, this was a critical 10 vulnerability. Now, if you think that I'm giving you a, big narrative because I'm in cybersecurity, it's not just that. It's because we've seen this, and I'm very concerned that history will be repeating itself. The last major vulnerability that we saw, where there was not a massive and global remediation, appropriate level of remediation, was really the struts vulnerability. Now, what I want you to really understand from this slide is that the 0 day that this vulnerability was announced was several months before the major Equifax breach. There was time for those enterprises to become secure, to get scanning, to become aware, and to make those fixes. But they left their systems insecure, and they gave months for malicious actors on the other side to be able to take action. Now, I was just on a podcast today, and I heard something that really rang true to me, is the understanding that the malicious actors on the other side of this are not just a hacker in a hoodie in a room working alone. It's good to understand that these are very sophisticated. They typically are organized, and that the hacking organizations on the other side of these breaches also do Scrum. They are organized. They potentially may understand your code base better than you do. They have to be able to exploit it. So if you do not have that level of security understanding, they might, and they will exploit that. So there's a few quick wins that can ensure that you are ready for this kind of supply chain attack and that you are secure against it moving forward. Some of the general advice that I can give you is to make sure it's becoming regulated. You're going to have to do this anyway, but it is best practice to create an SBOM. So that is your standard bill of materials. So your software bill of materials in this case. You have to know what's in your code. You want to know what your components are and what their dependencies are and what the relationships are between those dependencies. It can still be that if you eradicate every case of Log4j, there may be an open source component that you are dependent on, which is utilizing that. And that still puts your system at risk. You need to apply the latest updates and patches, but we're going to talk a little bit later on about how to do that intelligently, because it's not a matter of just turning on Dependabot. In fact, it is that what was considered standard best practice of just regularly updating to the best version, which has created a way of a new vector of them to exploit that. Oftentimes, just by putting a variation in the namespace or putting a bad pull request that allows for malicious code to go into that newest version, and that can't always be captured in real time. You need to verify the integrity of your code. You need to make sure that you understand what goes into it and who put into it, and specifically the timestamps behind it. You want to have not just your SBOM, but really make sure that you know the timestamp of when and how these things are going into your code. Without that, you will lose information and you will not be able to verify with integrity. And you need some kind of automated deep binary analysis. You need to be able to be looking at your code, scanning it entirely, and making sure that you're spotting malicious code before it goes into production. Our tools are improving for this. As I stated before, it's not sufficient to do just a top-level scan of your code. You really do need to look at obfuscated or minified code. One of the major reasons, as I said before, 40% of these downloads are still vulnerable is very possibly because they're sitting in your jars and your Uber jars. You're not going to be able to see that unless you open those up and look at them. You're not going to be able to see that unless you have a really good way to look at those subcomponents. These sophisticated techniques that we can start to use here may be needed in sort of usage along with our cybersecurity researchers. This is something that I'm not going to go into a lot of detail into now. We're seeing this as a new approach, but really when I'm talking about Log4j, I'm talking about a more traditional approach of having a vector to put malicious code into whatever source code that a malicious actor may be intending to. But for all of these, we really want to be careful about doing basic perimeter controls. Make sure that you're monitoring. This is really where cybersecurity and site reliability engineering are starting to blend together. Your monitoring needs to make sure that you're looking at your CPU usage. Is there any spiking? Is there anything strange? Is there anything that doesn't make sense for the working architecture that you intend? If that's the case, you might be able to find, just by the alteration in the behavior of your system, a malicious code that's coming in. Now, as we move on to understanding how versioning and open source behavior can affect our best practices, we really need to consider what it looks like to have best practices. As we are moving to continuous integration, continuous delivery, we need to think about continuous monitoring in a way that allows us to do continuous security, right? If 650% more cybersecurity threats are coming in through the open source supply chain just between 2020 and 2021, I am curious to see what the statistics look like for this year, and we are living through that right now. If you are doing this in a pretty poor approach, you might have a sort of unmanaged approach to this, or you're exploring understanding the best way to monitor this. You might be doing this ad hoc. This is really enterprises. They're at the level of doing these fire drills, making sure that they can be prepared for certain types of attacks, but not all of them. Most enterprises now are in a state of control. They are monitoring, and when a problem comes up, they are able to deal with it in an ad hoc way. But really, this is decelerating or bringing to a halt your feature development. If we move to the most mature way to be dealing with this in an enterprise, we need to monitor and measure. So we need continuous monitoring. We need to see security as being something that we see as something moving into the domain of something closer to site reliability engineering. We need to be able to capture these events in real time, take them down, and be able to work with our production code to make sure that we have our runtimes continuous and our security continuous in the same way. And I'm going to give us some metrics that are going to help us to do that at the end of this talk. So let's talk about what best practices were and how they're starting to be exploited. So most of the best practices that we have really function on a behavioral level. So don't choose something that's alpha or beta. Don't choose something that's experimental. Don't upgrade to a known vulnerable version. These are all known. Upgrade to a lower risk severity from your current version if there's nothing that's entirely not vulnerable available. These are pretty much givens. And when something's published in quick succession, typically you want to install or download the one that is newest to the time that you are trying to composite your code. Now, you don't want to make subjectively bad choices. You want to choose a migration path that others have chosen. So this is herd migration. We'll discuss that. Choose a version that minimizes breaking code changes, but again, don't make the easy choice over the most secure choice. These are things that have to be subjective. They're things that you may want to have a discussion about with your security and your development team in the same room. Choose a version that the majority of the population is choosing. I did state before that the most popular packages are the ones that are most likely to be attacked. They're also the ones that are most aware. So if there is information that gets out about a potentially malicious version, be paying attention to that in the download rates and ensure that you're downloading the one that most individuals are going to. This is something that in the next 2 years, we might not be using as a proxy any longer, but this really is one of those subjective tools that you can really be looking at different versions when you're making that decision. And when all else is tied, do choose the newest version, but do it mindfully. And I'm going to tell you why. So this graph, I'm going to unpack a little bit for you. This is looking at a single piece of open source software and the versions that have been developing over time. You'll see anywhere from 4.0 to 5.3 as we go from left to right on the screen. Red means a highly vulnerable release. Going into the blue means a vulnerable release with some updates. And green is really the green, good to go, cutting edge. Now, I think what's really interesting in our study of this specific package was that the very, very bleeding edge components, if you're using Dependabot, for example, you'd be sticking on this entirely green edge. Yes, they were less vulnerable, but on average, the best version to use for this specific case was actually about 2 versions behind the bleeding edge. Not because it was less secure. In this case, the cutting edge of this component was the most secure as they were paying attention specifically to security, but they had to work out some bugs in the new features that they developed as well. So you really want to be looking at, yes, what is the cutting edge here, but what is the herd behavior telling me is the best version, and balance between those. And for example of what this herd behavior can look like in practice, here is a look at what the majority of movements were looking like for those that were high performers and low performers. And really what you need to take out of this is that it was those teams that made the choice to regularly and mindfully update to the latest version that were able to stay the most secure. If you're seeing these little jumps in time, that is what that looks like. If I'm not telling you anything new here, I might be giving you a little bit of incentive to go back to your teams and talk about the reasoning why. And when you're making these decisions, take a step back and say, is it something that's going to break my code? Do we need to refactor this? Or can we be doing a more progressive and continuous delivery to allow us to work in this way? Because you do not know when the next attack is going to come in, and there has to be a as near to real-time update, not just of that software on the open source supply chain side, but you have to really bring it into your system. You have to mindfully bring it into your system. And all of this represents a change that we've seen as we've moved from sort of these monolith architectures that we were building a couple of years ago to the way that everyone builds today to build effectively. We build microservice architectures. Now, originally, you would be able to have an architect come into the beginning of a project, give you what best practices would look like for a specific stack or a specific architecture, and you'd really be able to work with that. But now it has changed from us trying to make decisions around what does the best architecture look like to also having to make micro dependency decisions. Now you have to make the decision on what does the overall architecture look like, but also what are the packages that I can put into place that I know are going to be regularly updating so that I can regularly update so that my surface area is always green, good to go, and free of malicious attack vectors. And if you think that I have given you any information that you didn't already know, these are things that I assume we all know as best practices, but unfortunately, in a study done just last year, it was found that 69% of dependency management decisions specifically, so not architecture decisions, these micro dependency management decisions are actually suboptimal. So this means that 64% of development teams were choosing imperfect or suboptimal versions. This means either not just the most up to date, so choosing one that's a few versions behind more than the optimal version, or choosing not to update at all. And this 31% of optimal decision makers making the right choice for the right version in real time is something that I really want us to be moving the line on. I want to see this be shifted by 2023 to 65, 70% of developer teams knowing how and why to make the right decision. And if you need to defend that within your organization, because yes, it may take a little bit of time to be doing regular refactoring, but that is much less expensive than having a major breach. So how is it that you can go about making this decision well? Now, there are a couple of ways of doing a traditional approach to choosing good packages. Now, we had source rank, which really aimed to get to the quality of open source software. This focused primarily on documentation, whether the community was responsive, how well supported it was. And that's not a bad metric, especially if you're engaging with them and trying to get new feature development out of them. None of these are mutually exclusive. You should consider using all of these. OpenSSF's criticality score really tried to take a more quantified approach to this. So they are measuring the community, the usage, the activity, and they distill this into how critical a project is to an open source ecosystem. So this is kind of bringing a proxy to how many people depend on and care about this. Is that likely to make this a more secure, more usable, more reliable software? Now, I would kind of make the argument that looking at Log4j is a perfect example of something that has a high criticality score and yet was still able to be attacked. This is something that is still a great metric, but it really came out of a time and a space and a reasoning potentially that isn't appropriate for the world that we're moving into as software development accelerates, as the open source supply chain accelerates. And that's why I really want to propose to you that you start using the mean time to update. So this is a quantitative measure that looks at how quickly a project moves to update their dependencies. Lower in this case is faster, or is better, and a higher MTTU means that they have a very slow time to update. So what this really means in practice is that just as you on your known development team are doing your best to refactor, update, and keep your system free of vulnerabilities, you need to be able to have that same expectation of the packages that you're pulling in from your open source repositories. So to dive into a little bit of how we calculate this, you can look at this little diagram here. So for a given component, so say this is a single open source package, what we can do to calculate the mean time to update is examine every version of dependencies within it. Again, they all have their own code bases. They all have their own dependency tree. They may potentially all have their own SBOMs very soon, which will make this much easier. Then we calculate the time between when that version was released and when they release a new version with that dependency update. So are they doing the work to have that hygiene around dependencies? Because this is where a lot of these vectors are coming in. And then we compute the mean or the average across those, giving ourselves a nice round number and one that we can actually take into as we're looking at what is the MTTU of some of the packages I'm pulling in. Makes it very easy to calculate on a sheet of paper what the MTTU is for your source code. And that allows you to have a ground source of truth, an excellent KPI, an excellent SLI that you can take and use within your enterprise to make sure that you keep that level or improve it over time. So I want to be clear that this doesn't directly measure the speed at which projects fix publicly disclosed vulnerability, but it does strongly correlate to a project's mean time to remediation. Now, if this is something that you have as something that you are at a service level required to attend to, as most enterprises are, I think that this is incredibly important. And this is what really stood out to me when we did this research in 2021. MTTU is a metric that allows us to determine what the potential impact a component will have on your source code before you bring it in a way that we have not been able to get previously. And the fact that it is so strongly predictive of MTTR really stands out to me. And it's the reason why I am not here on a soapbox to tell you this is something that you might want to use. I'm here telling you this is the only thing out there right now. And yes, I am looking for other ways to have composite analysis to make this even better. There is nothing out there right now that has such a strong positive correlation to your MTTR. So really the reasoning behind this is that you're making sure that you have a less vulnerable or a less likely to be a less likely package to have a vector come into it, or one that will be captured before it even gets into your code base, knowing that you can make those regular updates, make those regular refactors, and have a surface area that's not vulnerable. This naturally is going to flow over to your MTTR because you know where the components are, you know how to update them in real time, and your mean time to remedy is now going to go up substantially because of that. You know which of the packages are likely to be vulnerable or likely to not be vulnerable. That already lowers down your scope of understanding where is this attack coming in. And you also know what is their cadence? How often are they making an update? Do I need to be considering an alternative because this open source package may not be likely to make an update if they have a really bad MTTU? When you think about it this way, this is our way of stepping into this new way of doing cybersecurity in a way that puts us in preventative resilience. We need this way of working because this is only getting faster. And I say this with stats behind this. So MTTU, as we look at this across time for a couple of years, has been increasing. It's not just the case that enterprises are trying to get features out more and more rapidly. It's the case that open source is also making these updates, in part because there are more developers in those space. There's more people reliant on it. There's a better relationship between enterprise and open source globally. But when we're looking at this in 2011, it would take over a year typically for there to be an update. We are seeing now that that has gone down to just a month. This could potentially be at the rate of a sprint inside of 2023. Now, if we're looking at that, that means that you could be having components and subcomponents of your source code needing to be updated every sprint. You want to be smart about that. You want to know why you're making those decisions. You want those to be defensible decisions. And having a quantitative reliance on metrics allows you to know when and why you're making that decision in a really good way. So in this discussion today, we've covered really why there's been an explosion of open source contribution in the last decade. We've covered how malware attacks in open source have and definitely will exponentially increase. It's just too easy for organized malicious actors to be going out and trying to do this en masse. Again, when we're seeing exploitations of the open source supply chain, they're no longer going after the biggest enterprises in the world. They're going after the most utilized open source components so that they can get a smattering of large and small enterprise, and everyone is attacked equally. We need to evolve the open source supply chain with vulnerability metrics that allow for optimal decision making. You need to be quantitative about this. You cannot be qualitative in the way that we are moving into a world that's going to speed up the way that not only we can deliver new features, but the way that malicious actors can engage. And lastly, we are all responsible for the maintenance of the open source projects that we rely on. We can evolve best practices for vulnerability detection at an ecosystem level. That's exactly what Sonatype is aiming to do. When I showed you all the vulnerabilities that we've captured over the last couple of months, again, we were not just putting these out as information to the public. We were making sure that those vulnerabilities were removed at the source so that they never went into your source code. And it's evolving to that level of having a global accountability and a global responsibility for the way that open source allows us to do our work so well, but brings us new and unexpected risks that we all need to have an awareness of. So if you have any questions, we definitely have a little bit of time, but I wanted to highlight a couple of resources that I leaned on a little bit in this presentation, but that you should definitely explore and that you should take back to your own organizations because they are essential. So some of the statistics that I pulled from were from the State of the Software Supply Chain from 2021, which you can find on our resources page. We cover all of the major ecosystems, some of the special variabilities within those language logics that make them more susceptible to specific types of attacks, and why you should be aware of those for the types of technical stacks that you depend on. I've highlighted the vulnerability timeline. I would encourage you to go look at that, understand what these are starting to look like, and allow yourself to see how they have begun to be evolving over time. Again, cybersecurity and malicious actors in cybersecurity, they're very creative, they're very motivated, and we need to understand how to think a little bit more like them in order to be able to compete against them. And always, if you have not yet, please do go to the Log4j Vulnerability Resource Center. This is going to show you from Maven Central Repository in real time the vulnerable downloads that are still being captured into source code. This scares me a lot because of the consequences that it can have, but it can also be a way for you to go back to your enterprises and say, hey, look, are we sure that we are secure in this case? Are we certain, or do we need to take a second look to make sure that we are definitely that 60% that is no longer vulnerable and not the almost 50-50 chance right now? Again, it was 44% bad downloads middle of the day today. There's an almost 50-50 chance that you are somewhere in your code or somewhere within your dependency chain still bringing in one of the biggest malicious vectors that we have seen in a decade. And that's important. You need to reflect on that, and you need to go through and make sure that you're not just doing fire drills, that you're ensuring that you're doing that deep analysis of your code and surfacing any potential spaces where that could still be hidden. Now, if you do go to that page, we are offering a free scanning that goes through and gives you not just any vulnerabilities that are bringing up Log4j, anything else that we can find in the major ecosystems that we do support. And we provide you an SBOM along with it. So if you are part of taking that journey to continuous delivery, continuous monitoring, continuous security, this is a really cool, free, 2-click way to install our Lift security scanner. And that is going to be free forever because we have made that not as a way to bring you into security awareness. Really, for us, this is something Sonatype has been there since the beginning of Maven Central Repository. When we see things like this is a way to give back to a developer community that we really grew our business on. And we want you to be able to make sure that you are secure. We want to make sure that the Java community is secure. And we want to make sure that every new language that has developed into this space, we're looking at Rust, we're looking at Golang. If you are out there developing new architectures, there's probably still Java in it. This is still 2022. The internet still runs on Java. Make sure that you go through, do a scan, and see if you're not surprised. So with that, I'm happy to take any questions if they come into the chat. You can also reach out to me best on Twitter at Kimmich_compute. I'd be happy to take any of your questions. And in just 1 week, I will be going into a little bit more about how the acceleration of the open source supply chain has drastically changed the way that we need to approach the culture around PagerDuty for DevOps, site reliability engineering, and cybersecurity, and how those are beginning to become a single identity. The ways that we can use our service level agreements to ensure that we're working cross functionally and step into the future of open source development where things are getting really cool, really exciting, and a little bit scary. And as long as we protect ourselves, we have an awareness and we have the metrics to back up what success looks like, we've got no reason to be afraid. We can go on, continue to develop, keep our services running, and really be excited about what open source is going to look like in the next few years. So thank you so much.
And Sal, thank you so much for being here with us today. I'm looking through our chat and Q&A, and I'm not seeing any questions that have come in. So I will give our audience another minute or two to rack their brains for anything while we give away a couple of gift cards. So the first of our 4 $25 Amazon gift cards goes to Nancy L. Our second winner is Lubov P. Our third winner is Lena S. And our fourth and final winner is Sam B. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. And I'll also take this opportunity to remind our audience that today's session was recorded. You'll receive a copy of the recording shortly after we conclude, and you can also find it living on the DevOps website. Just visit devops.com/webinars. So Sal, I'm not seeing any more questions coming in, so I have to assume that you have answered every question preemptively.
Wonderful.
Awesome. So I would also like to extend our eternal gratitude to Sonatype for sponsoring today's webinar. And my final thanks goes to you, our audience. We really appreciate you being here with us today. We hope to see you next week at the Sonatype workshop that Sal will be putting on. And we also hope to see you at other future TechStrong Learning webinars. So thank you all so much for being here with us today, and have a great rest of your day.
Thank you.